Can you see the board?
Yes, sir.
Okay, first let me show what is line integral. Before that, I must recall a single integral. So first of all, my question is what you can understand from this single integral, or what is the information that can be obtained from the single integral. If someone asks you, what do you mean by this single integral? Then what would be your answer?
The area under the function's curve.
Sorry,
This represents the area under the function's curve.
anything else? So if the function curve is like this, so which area? Of course, this is x-axis, this is y-axis. So which area you are saying this one?
Sir, under the curve and above the x-axis, and holding some bounds.
Yes,
Bounded.
that is very important. You must have this one, x equal to a and x equal to b. These are the parallel to y-axis, and the upper boundary is the function y equal to f of x, and lower boundary is the x-axis itself. Then this portion, the area of this one is given by this integral. Okay? But this is not our concern. Our concern is, look at here, this single integral is defined on the x-axis. Not only on the x-axis, a particular portion of the x-axis. Which portion of the x-axis where this single integral we have defined? Only this part. Is it okay? The integral is defined between a and b, and a and b occur on the x-axis. So this x equal to a and x equal to b basically indicates a certain portion of the x-axis where this integral is defined. Understood what I am saying? Is it okay? The red,
Yes.
the red portion, it is a part of x-axis where this integral is defined. Now, if I draw this red portion in a separate region, sorry, not region, if I draw it separately, then what would be your comment on this part where this integral is defined? I mean, what is its shape?
It's a straight line.
Exactly, straight line. This is the most important thing that we are looking for. The single integral is always defined on a straight line, and that straight line is a part of x-axis. Understood? Whatever the single integral is, always it is defined on a straight line, and that straight line has to be a part of x-axis. Understood? Is it okay?
Yes.
Okay. Now, if we need to define, if we need to define a single integral on this curve, suppose here x equal to a and x equal to b is here. We want to define a single integral on that curve. Unfortunately, it is not a straight line. So the traditional single integral or typical single integral does not work here. Understood what I am saying? If you want to define an integral over a curve, not a straight line, then the typical single integral or traditional single integral does not work. You cannot use it to define an integral over that curve. In that case, you must need special treatment for an integral. And that special treatment is the line integral. Understood what I am saying? This is the basic difference between a typical integral and line integral. Is that okay? This is the primary motivation why we need to use line integral, because we already learned so many integrals, different techniques, different aspects, different applications. So why we need line integral? This is the basic or fundamental motivation of line integral. Of course, we will move to the mathematical part, but this is the intuitive motivation. Is that okay, or any question? Is there any question?
স্যার আমরা ওয়েল যখন ওই স্ট্রেট লাইনটা দিয়ে ইন্টিগ্রেশন সিঙ্গেল ইন্টিগ্রাল ক্যালকুলেট করছিলাম তখন তো এরিয়া বের করছিলাম তাই না?
Yes.
তো সো এখানেও কি এরিয়াটাই ক্যালকুলেট হবে জাস্ট
No,
একটা
no, that
কার্ভের
is a
মতো?
different issue. I'll show it later. This is the last part, how and where we can apply. To find the area of a region, it is an application of an integral. Now we are talking about how to define a line integral and what is its aspect. And second part is how can you solve it. And third part is how and where we can apply it.
ওকে স্যার।
Okay, so now let me define. Look at here, line integrals. The discussion that I have already mentioned here, everything is written. Suppose you have a curve like this, where you should define or you need to define an integral. In that case, the traditional or typical integral does not work. And line integral has vast applications in science and engineering. I will show it later. So, what is the mechanism, mathematical mechanism behind a line integral? As I have already mentioned, line integral is a special type of single integral. The rest of the things are almost the same, but the definition is slightly different that I have just mentioned now. It is defined on a curve rather than a straight line. So the curve has to be splitted on some small part. Okay, so for example, this one, if you split it in some small part, then each of the parts has to be considered or can be considered as a straight line. Is it okay? If you split this curve, although it is not a straight line, but if you split it in some small parts, individually each of the parts can be treated as a straight line. Is that okay?
ইয়েস স্যার।
That is the mathematical mechanism to define a line integral. Okay? So now let me show this is the definition, mathematical definition. Look at here. Look, how can you, first of all, how can you recognize if a single integral is given? How can you confirm whether it is a line integral? So there is a significant indicator by which you can confirm whether it is a line integral or not. This one is C. If you have a single integral, at the bottom of the integral, if you have this symbol C, you can confirm it. It is a line integral. It is not a typical single integral. Understood what I am saying? This is the most easiest process to confirm whether a single integral is a line integral. So you must have a single integral, and at the bottom of the integral sign, there must be C or S, something like that. Most of the cases, it should be C. Then you can confirm it is a line integral. And that line integral is defined on the curve C. C indicates the curve where the line integral is defined. Understood? Is that okay?
So, আবার একটু রিপিট করা যাবে?
Of course. Okay, let me use this one. Then that is more convenient. Okay, can you see the screen?
Yes, sir.
Okay, so look at here. This is the definition. Okay, so someone asked a question. What is the question? What was the question? I did not notice. Sorry. Should I explain it again?
Yes, sir.
Okay. So look at here. First of all, how can you recognize a line integral? As I have already mentioned, it is also a single integral. So at the bottom of the single integral, if you see this sign C, then you can confirm it is a line integral. Okay. If you have an integral like this, you have to understand this. It is a line integral because at the bottom of the integral sign you have C, and that C indicates the curve where this line integral is defined. Of course, the description of C must be given in the problem. The description of C is a curve where this integral is defined. That's why it is a line integral, and the description of C should be given in the problem. Is that okay? So now, first I want to show how can we define a line integral and how can we find the value of a line integral, because this is the most important thing for us. Is that okay? Look at here. Here I have written a typical or standard form of line integral. Look at here. What are the information here? What are the information here? Here we have C. What is C? C indicates a curve where the integral is defined. Understood? What is f? F is a function which is going to be integrated. F is the function, and we want to integrate that function over the curve C. And what is ds? ds is, suppose C is this one. This is the curve C. What is ds? ds is a small part of the curve C. I repeat, ds is a small part of the curve C. Understood? I repeat, C is a curve, of course, smooth curve. I think you know what is smooth curve. There should not be any sharp point or corner point. That is called smooth curve. C must be a smooth curve, and f is a function. And what is ds? ds is a small part of the curve C. Understood? Is it okay? Now,
Yes, sir.
at a glance, can you see or can you observe any difficulty to find the value of this line integral? Even you have all the information, can you see or can you observe any difficulty to find this integral, to find the value of this integral?
Sir, the function is in x and y,
Yes. Is it a difficulty?
but we are using ds, right?
Basically, this is not a difficulty. The difficulty is here we have a function of two variables, but we have a single integral. This is the difficulty. Yes, we can express it in terms of x or in terms of y. This is not a problem. I will show it later. But at a glance, we can understand that the difficulty is here we can see it is a function of two variables, but we have single integral. This is the most important difficulty. So, what should we do? We have two possibilities. One is we can transfer this two variable function to a single variable function. Hello, can you hear me?
Yes, sir.
No, what is the problem? So, as I have already mentioned, the difficulty is it is a two variable function, but we have single integral. So we have two possibilities. One is we can transfer this two variable function to a single variable function. That could be one possibility. Another is we can include one more integral as we have two variables. So if you can make this double integral, then it is compatible or it makes sense. Understood? Is it okay? So in that case, we must consider the most convenient one is the first possibility. The first possibility is we want to transfer these two variables to a single variable. And how can we do that? We can do that if we use parametric equations. I repeat, if we use parametric equations, then both x and y have to be transferred to a single variable t or something like that. Then this line integral will be a standard typical single integral with respect to a one variable or single variable, so that we can find its value smoothly or easily. This is the process. Of course, mathematically I will explain. Understood what I am saying? We must use parametric equations of the curve. We must use parametric equations of the curve so that two variables can be transferred to single variable, and subsequently we can evaluate the single integral. Is that okay?
Yes.
I don't know why we have this problem today. Okay, now let me show a standard example, then I move to the exercise. So look at here. Everything is mentioned that I have discussed or described just now. How to evaluate line integral, the evaluation process. It is mentioned here. You may have a look. Look at here. Just have a look. It is a standard line integral. How can you recognize or how can you confirm it is a line integral? Because at the bottom of the integral there is c, and at the end of the integral we have ds. These two information confirms that it is a line integral. At the bottom of the integral you have c, and at the end of the integral you have ds. These two are the important indication of line integral. Understood? Is that okay? Now, if you have parametric equations x equal to x of t and y equals y of t, then x should be replaced by x of t, y should be replaced by y of t. And you must look for what is the minimum value of t at the starting point of the curve and what is the maximum value of t at the end point of the curve c. This starting point, at the starting point, the value of t should be the lower limit, and at the end point of the curve c, the value of t should be the upper limit. Now we have ds. What is ds? Okay. So can you recall arc length? Have you ever heard this word, arc length?
Yes, sir.
What is the formula for
It is
finding arc?
root over 1 minus uh, in brackets dy by dx whole square, I think, as per the
Sorry.
square root of 1 minus dy by dx whole square, something like that.
Square root of 1 minus Why minus? Are you sure?
Sir, I know.
Yes, I think plus.
Alright.
Okay. So basically, ds is the arc length mathematically. Of course, it is a small part of the curve C, but mathematically it indicates arc length. So what is its value? What is its value? I mean ds. You can use the arc length. So square root of something like this, dt. Okay. So now let me show this one. This is the most convenient technique to find the value of a line integral. Look at here, it is a line integral. Due to the parametric equations, x should be replaced by x of t, y should be replaced by y of t, and ds equal to this one. Okay, ds equal to this one. Of course, you may have a doubt about the value of ds, but I can clarify. Look, maybe you have this one, right? Is it okay? The value of ds, is it okay? Or something else? Okay, I can show you here. Look at here. If you have a curve like this and if you divide it in some small parts, this part is called ds. Let me use different color. This part is ds. So now, what is this length? Because it is a part of a curve, you may use the formula of arc length. And how can we use it in terms of parametric equations? That you must remember. We are transferring two variables to single variable. And if you have parametric equations like this, then ds equal to this one, dx dt whole square times ui dt whole square times dt. Understood? So this is the value of ds that has to be incorporated when you are going to find the value of a line integral. And it should come from the parametric equations. Okay? Look at here. And there might be two possibilities, two variable function or three variable function, same process. Just one extra variable will come out if you have three variable function, but the main mechanism is exactly same. So what should we do here? We must know the parametric equations of the curve C where the integral is defined. From where we can transfer both x and y to a single variable. We can transfer ds in terms of t, and we can also extract limits for t. And how can we extract the limits? We can find the lower limit for t from the starting point of the curve, and we can find the upper limit of t from the end point of the curve. Okay? Is there any question? I want to show the simple example, then I'll move to the exercise. Look at here. Any question if you have, you can ask me. Is there any question? No? Okay. So look at here. Look, This is the line integral that we are going to evaluate. Of course, it is solved. Yeah. First of all, you have to confirm, is it a line integral that I have written here? Is it a line integral?
Yes, sir.
How can you confirm it is a line
Because of
integral?
C,
Because of C and ds.
DS, yes.
Okay, fine. So we want to find its value. As I have already mentioned, and I repeatedly mentioned that it is a special type of line integral, so traditional technique does not work here. You must have a special treatment, and that we are learning here. What is the special treatment for such type of line integral? Okay, so when you are going to find the value of a line integral, or you are going to evaluate a line integral, you must remember, or you must be very careful about C. What is C here? Okay, what is C? Look at here. The C is mentioned here. The parametric equations are given. And it starts from 1, 0, 0, and it ends at minus 1, 0, pi. And what are the parametric equations? X equal to cos t, y equal to sin t, z equal to t, where t lies in between 0 to pi. All the information are given here. So in your function, x should be replaced by cos t, y should be replaced by sin t, z should be replaced by t. And since throughout the curve C, the variation or the lower and upper bound of t are mentioned here. The lower bound of t is 0, the upper bound of t is pi. So this integral should have lower limit 0 and upper limit pi. Understood? Is that okay? And look at
Yes,
here,
sir.
x is replaced by cos t, y is replaced by sin t, z is replaced by t. And of course, you must find the value of ds. The formula that I have mentioned just now, ds equal to square root of dx dt whole square plus dy dt whole square plus dz dt whole square times dt. Okay, so what is dx dt? You can find it from here. Dx dt is minus sin t. What is dy dt? Dy dt is cos t. What is dz dt? Dz dt is 1. And finally, you will have this one. And then you can easily integrate it and you will find its value. This is the process to find the value of a line integral. Understood? Of course, I will show one problem from exercise. But I just here I wanted to show the total process or whole process to evaluate a line integral. Is that okay? Understood? Or any question? No question? Okay, just one problem I want to show here. Look at here. From exercise, look, evaluate the line integral along the curve C. So let me show number 24. So look at the problem number 24. Okay, no, number 24, a different process. First, let me show it from here. From 19 to 22, I want to solve one problem. Suppose 20. So look at here. First of all, is it a line integral?
Yes,
Yes.
sir.
Okay, fine. So we want to solve it. The question is, how can we solve it? How can we solve it? The parametric equations are given, but sometimes parametric equation might not be given. And I think you know how can you find the parametric equations. But most of the cases, parametric equations are given. For example, like 20 or 19 or 21. The parametric equations are, if the parametric equations are given, this is easier for you. You just put the parametric equations and evaluate the integral. Okay, so how can we solve it? We have to transfer
Substitute.
x and y in terms of t as the parametric equations are given, and the variation of t is also given throughout the curve C. The minimum value of t is 0 and the maximum value of t is 1. So you can easily understand what are the limits for the integral. Okay, and ds, you know what is the value of ds? Ds should be this one. Ds should be this one. Understood? Okay, so let me solve number 20, then I'll move to different problem. Okay, so let's solve. Here, the parametric equations are given. X by 1 plus y square, x equal to 1 plus twice t, y equal to t. These are the parametric equations. These are given. And here the function is x over 1 plus y square. Okay. So x should be replaced by 1 plus 2t. Y should be replaced by t square. And ds should be dx dt whole square. And here the variation of t is given. The variation of t is given from 0 to 1. Okay, so now tell me what is dx dt? What is dx dt? Can you tell me? What is dx
2.
dt? 2, yes. 2 square. And what is dy dt?
1.
1. And finally, what we have? 2 square, 4 plus 1, 5. So square root of 5, it is a constant. We can take it off and look at here. May I write it like this? Can I have this one? Is it okay? So now tell me, it is a typical single integral. We have converted the line integral to a typical single integral so that we can find its value. So now tell me, what is the antiderivative of this one? Can you tell me what is its antiderivative? 1 over 1 plus t square?
So tan inverse t.
Yes. Tan inverse t plus, what is its antiderivative? 2.
Ln 1 plus t square.
Yes. Because the derivative is twice t. Derivative of 1 plus t square is twice t. So now put the limit. So if you put the upper limit, tan inverse 1 plus ln2 minus tan inverse 0 minus ln1. What is the value of tan inverse 0? Any idea? No idea? Tan inverse 0?
Sir, 0.
0, yes, 0. And ln1? 0,
0.
yes. So finally what you have this one. You may keep it here or you can find the value of tan inverse 1. I think tan inverse 1 is pi by 4 and ln2 you will have a value of ln2. If you want, you can do that or you can keep it here. So this is the process to find the value of a line integral. Understood?
Yes.
Okay. Now I want to move to a different problem. Different problem means line integral can also be defined in terms of a vector field, I mean vector value function that we learned in the last class. I repeat, line integral can also be defined in terms of a line integral. Sorry, in terms of a vector valued function. If it is defined in terms of a vector valued function, then what will happen? How can we find this value? And what is the process that we want to understand now? Okay, so let me show. Okay, so here from 19 to 22 we have same process. Okay, you may ask me if you have a vector, then what will happen? Same process. Vector means x of t equal to this one, y of t equal to that one, and z equal to t. Understood? And here also x equal to t, y equal to 2/3 t to the power 3 by 2. And you should follow the same process that I have mentioned. Okay? Okay, now vector valued function. If we have, then what will happen? In terms of vector valued function, how can we define a line integral, or what is the form of the line integral or structure of the line integral? Look at here. If capital F is a vector valued function or vector field, is a continuous vector field, and C is a smooth oriented curve. I think you know smooth curve, and do you know what is oriented curve? Have you ever heard the
It has a
oriented?
certain direction to it.
Exactly. The curve should have a certain direction. So smooth oriented curve, C is smooth oriented. Why the direction is important here? The direction is important because the integral is defined in terms of vector field. So look at here. That's why the direction is important, because the integral is defined in terms of vector field. Look at here. This is the standard structure of a line integral in terms of vector field. Look, here f is a vector valued function or vector field. C is a smooth oriented curve. And dr, what is dr? This is also an important issue here. What is dr? Can you tell me what is dr? And you have to understand what is the difference between ds and dr. Since capital F is vector field or vector valued function, so the arc length or the length of a small part of the curve C has to be defined in terms of a vector, and that vector is dr. Understood? And that vector is dr. Is that okay? And what is the value of dr? Dr equal to dxi plus dyj in 2D. If it is in 3D, it should be dzk. This is the difference, basically. Understood?
So, sir, dr is the individual vectors that make up the whole smooth oriented curve.
No, no. dr, we can call it differential vector.
Okay.
Differential vector. Why this should be a differential vector? Because your f is a vector. That's why the differential operator or the differential that you have to put here, it must be a vector. Otherwise, it has no meaning. This is the idea behind it. Okay? So now what we want to learn here, we want to learn how can we evaluate a line integral if it is defined in terms of a vector field. Okay? So the process is not so difficult. The process is almost same. Look, so you should know a position vector along the curve C. I repeat, you must know a position vector along the curve C. And that position vector is defined by R. Okay? And from that R, you can you can use the vector valued function capital F, which is going to be a single variable function as if it is a two variable or three variable function, and dr equal to r prime dt. Why dr equal to r prime dt, I will explain it, and then it will become a standard single integral, and subsequently you can find its value. Okay, so I want to recall an information from math 120. So can you tell me what is the difference between differential and derivative? Suppose y equal to f of x, its derivative is like this. And what is the differential of this function, and what is the relation between differential and derivative? Understood my question? Because this is important. That idea we have to use here. Understood what I am saying? No? Do you, no, not at all. Not at all. But this is very fundamental differential and derivative. Okay, let me give a very simple example. We don't have much time. Suppose today you have deposited 500 taka in your bank account, and bank will give you 7% interest on that amount. So after 1 year, how much money you are expecting? Understood my question? You have deposited 500 taka, the interest rate is 7%. After 1 year, how much money you are expecting? You don't know? Come on.
535.
500.
535. Why 535? Why not 545? Or why not 575?
Because we have a fixed interest rate.
Yes. This 7% is the derivative, rate of change. Your money is changing according to the 7%. If it is 9%, it should be 545. It should not be 535. That means your money is changing according to this rate. This is the rate of change, I mean derivative. Understood?
Yes.
And how much change you have? You have deposited 500, now you have 535. So What is the change?
35.
35. This 35 is the amount of change, right?
Yes, sir.
And this 7% is the derivative, and this 35 is the differential. So big difference. Understood?
Super.
Derivative is the rate of change, differential is the amount of change. So different meaning. Understood? Is it okay? Any more question? Now, what is the relation between them? Look, suppose I want to calculate amount of change. What is the amount of change here? 35. So, may I write like this? Possible. Is it okay? If you multiply 500 by 7%, can you have 35?
Yes, sir.
Okay. So, what does it mean? So, this is the differential, this is the derivative. So, amount of change of y equal to derivative times amount of change in x. This is the relation between the differential and the derivative. Look, of y, I mean amount of change in y, which is equal to rate of change, I mean derivative of y, times the amount of change in x. This is the relation between derivative and differential. Understood? This is very fundamental discussion about math 1 to 0, the starting of the derivative. Anyway, so we have to use here, we have to use this one. Why I am showing this one? Because we have to use this idea here. So dr is the differential of r. So what is its value? Its value should be this one. Rate of change of r with respect to t and differential of t. Can I have that one? According to the relation, may I write this one? And finally, can I write this one? Look at here. Here it has been used. Understood? Is it okay? Any question? If you can understand, you should say yes. If not, you should say no. But you must respond.
Yes,
Yes,
sir.
sir.
Okay, so this is very important because we have to transfer dr. So now I want to show an example. If a line integral is defined in terms of vector field, then how can we find its value? The process I have already mentioned. And it has a very important application that I will show. Look at here. From 7 to 10, we have several examples. Look at here. First of all, it is a line integral in terms of vector field. Okay, in terms of vector field. So, how can we find its value? I want to show number 10. This is your vector valued function or vector field. And what is C here? C is a line segment in between P and Q. And you must know the position vector. I repeat, you must know the position vector along the curve C. So look at here. Tell me, where is 6, 0? 6, 2, 3, 4, 5, 6. 6, 0 is this one. Where is minus 1, 0? Where is minus 1, 0?
minus x-axis.
Here. Understood? So now, let me use different color. So this is your P, this is your Q. So now if you have a vector from P to Q, can you tell me what is the position vector? Can you tell me? Suppose P is the initial point, Q is the terminal point. So what is the vector PQ? Understood my question? Is it really difficult? Come on,
So 7i.
it should be like this. So R equal to 7I. Understood? Is that okay?
Yes.
Okay. So now I think you can find its value. I want to show a little bit complicated one. This is very simple one. I want to show this one. Look at here. No, no, not this one. This one. Look, here the curve C is given by three parametric equations. The variation of T is also given. So I think you know how to transfer it to standard single integral. You must remember one thing. When you are going to evaluate a line integral, your first target is to convert a line integral to a typical single integral. If you convert it to a typical single integral, you can easily find its value. Understood what I am saying? And what is the process to convert it to a typical single integral? The process is you have to use parametric equations. And here the parametric equations are given, and the limits of T are also given, and you know how to find the value of ds, so you can easily find, or you can easily convert it to the standard single integral. Is that okay? Look at here, the thing that I wanted to show. Look here. Look at this example. Look, here you have to evaluate this line integral, and this line integral is in terms of a vector value function. This is your vector value function. So look at here. This is your vector value function here, and what is C? C is given by this vector. So the vector itself is given. So this is more convenient for you when the vector itself is given. So what you should do, you should find r prime t, and look at here, this must be equal to, and suppose the first one t is from 1 to t. So here all x and x should be replaced, and what is dr r prime? T theta. And since it is a dot product, it must be a scalar quantity and you can find its value. And what is the process? Can you tell me what is R prime here for the first one? What is R prime? T,
J.
J, right. You are right. Only J. So R prime T equal to J. And what is F? F R prime T.
Sin X. Right?
No,
No.
no, look. What is the value of X? The value of X equal to minus pi by 2. What is Y? Y equal to T. Here, this is your function. Replace X. If
All
you
right.
replace X, then you must have this one. Cos pi by 2I minus sine pi by 2j. Now tell me what is the value of F? Come on. Cos pi by 2 equal to?
minus
Cos pi by 2 equal to what?
0,
0. And sine pi by 2 equal to?
1,
1. So you must have minus j. So what is the dot product of j and j? J and j?
1.
1. So you must have this one. And integrate, you will get the value. So the process is not so difficult, but you should know the process. Is that okay? Understood?
Sir, can you show the previous math for
Yes. You have to use the vector in the vector valued function. The vector will become a single variable vector valued function, and dr equal to r prime t dt. Why? I have already explained. And you must have the value of f and r prime. You must take the dot product. And if you take the dot product, vector will vanish. It must be a scalar, and you can integrate it. And if you integrate it, you will have this one. So this is minus 1. So the process is very simple, but you should know the process. Otherwise, it will be very difficult for you. Is that okay?
okay, sir.
Okay. So here I strongly recommend you first you should practice all the examples. Okay. Then you can practice some exercise. But one thing I can tell you here, how can or where we can apply this line integral. One of the most important applications of line integral is this one. What is this? Work performed by the force field on the particle. What is this? Let me explain a little bit. Suppose, look, work as a line integral. Work done can be calculated with the help of a line integral. This is one of the most important applications of line integral. If you have a force field must be described by a vector field. And if you have a force field and throughout the force field or over the force field, if you have a particle and for that particle, if it displaced or something else, and if there is some work done, and that work done can be found with the help of a line integral. Look at here. Suppose that under the influence of a continuous force field F, a particle moves along a smooth curve C, and that C is oriented in the direction of motion of the particle, then the work performed by the force field on the particle is. If you have a force field and a particle moves along a curve, the route or path of the particle, the motion of the particle is the path or the curve. Then what is the work done here? The work done performed by the force field is nothing but this line integral. This is one of the most important applications of line integral. Understood? And we have already learned how to calculate its value. We can call W equal to this one. So W equal to line integral along the curve C F dot dr. What is F? F is the force field here. What is C? C is the smooth curve which indicates the route or path of the movement or motion of the particle. And then the work done by the force field is this one. Understood? Is it okay?
Yes, sir.
This is one of the most important applications. Look, from 37 to 40, you should try to practice from 37 to 40. And here 19 to 22 and 45 to 48. That's all. And independence of path, this is not included. We are not interested. I think you all are engineering students, so you know this very well. If the vector field is conservative vector field, then it will be different. Something we have to incorporate more. So this is not our concern here. Our concern is one more thing, 15.4. So that I want to show today, and then I will finish. Look, first of all, my question is, what is this? If someone asks you, or I ask you, according to our today's discussion, what is this? What would be your answer?
Sir, it is the sum of two line integrals.
No, not two. It's a single integral.
Oh, sorry, that's dx.
It is a line integral, first of all, right? But the structure of the line integral is quite different that we have already learned, right? Here we have two, dx and dy. But previously we have two types of line integral that we have learned. One is for scalar function which contains ds. Another is for vector valued function which contains dr. But this line integral is quite different. Quite different means it contains two variable function and there are two variable functions. And one is end with dx, another is end with dy. So how can we evaluate such a type of line integral? This is very complicated one. Why very complicated one? Because it contains two functions and both of them are two variable functions, and it does not contain s. It contains dx and dy. That's why it is more complicated. Understood? So what should we do? In that case, mathematicians developed a convenient technique, and the mathematician is George Green. He was an English mathematician and physicist. He developed this technique, and according to his name, it is called Green's theorem. In case of integrals in vector valued function, or three special type of integral that we are going to learn now, there are three different theory. This is one of them, Green's theorem. And for that type of line integral, we have to use Green's theorem so that the line integral has to be or can be solved very smoothly. And what is the process that was developed by George Green? The process is, since there are, sorry, since there are two functions, so the most convenient one is if we convert this single integral to a double integral. Since there are two variable functions, and if we convert it to a double integral, then we can easily find its value, because we already learned what is the process to find the value of a line integral. So according to the George Green's theory or Green's theorem, we can transfer such, it is a very special type of line integral, not typical line integral. First, that you have to understand. That's why you must have a special treatment here. And Green's theorem is the special treatment by which we can transfer this special line integral to a standard double integral. Understood? And you must know the statement of this Green's theorem. Sometimes a question can be set, state Green's theorem, or write down the statement of the Green's theorem, just this one. Okay? So what is this? Both f and g are two functions. Both of them are two variable functions. What is C? C is a smooth curve. Not only smooth curve, smooth oriented curve and closed. Now, if you have smooth oriented curve, smooth, suppose this one, C. Since it is a closed, there must be a region inside the curve. I repeat, since C is a smooth, closed oriented curve, so there must be a region inside the curve C. If it is open, there should not be a region inside it. Since it is closed, so there must be a region inside C. And that region was taken by the George Green, and he taken this region as R, and he developed a technique so that this line integral can be transferred to a double integral. And what is R? R is the region inside the closed curve C. And look at here how he transferred it. The process is very simple. Look, you have two functions f and g. So both of them are two variable function. So you must take the partial derivative of g with respect to x minus partial derivative of f with respect to y. There is a technique to remember it. Look, with f you have dx. That's why you have to differentiate f with respect to y. And with g you have dy. So that's why you have to differentiate g with respect to x. Understood? So by using Green's theorem or this theory, we can find the value of this complicated line integral very smoothly. Understood what I am saying? Any question?
Yes.
Okay. So now let me show one problem. Of course, you should have a look about the example. I want to show one problem from the exercise. So from 3 to 30, use Green's theorem to evaluate the integral. Okay. So look, here you have a different notation. Of course, you should ask me what is the meaning of that notation. Look, if you have this one, what is the difference? Do you know the difference?
So it is showing that it is closed.
Yes. No, not surface integral. Not surface. Still, it is a line integral. Still, it is a line integral, but sorry. This is also a line integral, but here C, it might be closed or might be open. We don't know. But if you have this symbol, it is also a line integral, but we can confirm C is a closed curve. Understood? Is it okay? What is the difference between these two? And if you want to use Green's theorem, the necessary condition is C should be a closed curve. Otherwise, you cannot use Green's theorem. This is the necessary condition that you must remember. Anyway, number 4 that I want to show, number 4. So I want to finish. Sorry. So number 4, look at here. This is the line integral that we want to solve. And what is f here? Can you tell me what is f? What is f here? And what is g? For number 4?
So f
X
of x
square
is
minus y square.
Yes. And for g, this is x. Is it
X
okay? Fine. Now, del f del y and del g del x. What is del f del y?
minus 2y.
Minus 2y, right. Del g del x?
1.
1. Okay, fine. Now we want to apply here Green's theorem. So according to the Green's theorem, may I write like this? Equal to double integral over the region R del g del x is 1 minus del f del y. So can I write this one? This is the Green's theorem. Is it possible? Del g del x minus del f del y. Double integral over the. Yes? Is that okay?
yes, sir.
Okay. What is R here? Can you tell me what is R? What is R? R is this one. R is a circle. Radius 3, center 0, 0. So now you know the process how to find its value. Understood? Okay. So you should try it, and you don't need to solve all this problem. Just 3 to 10. This is okay. 3 to 10 from this one.
So limit গুলো কি সার্কেল থেকে বের
Yes,
করতে হবে?
yes, yes. You must find the limits from the circle. And it would be more convenient if you transfer it to the polar coordinates, or you can find it as it is if you want, no problem. But if you convert it to polar coordinates, the calculation will be more easier since it is a circle. Okay? So you should try from 3 to 10. So 15.1, 15.2, 15.3 is not included in our syllabus, 15.4. Okay? So next Thursday, I want to take a third quiz. The syllabus is this one. Is that okay? Or it is too large? Okay, so 15.1 is not included. 15.2 and 4. Okay? Only line integral. So quiz 3, of course, I'll make an announcement next Thursday, I mean 17. Okay? The syllabus is 15.2 and 15.4. And our next topic is surface integral 15.5 that we will discuss in the next class. Okay, so now let me take that, and then sorry I have taken much time today.
Uh, Sir,
Yes.
in the assignment, uh, the question number 2, it's on calculating the surface
Okay,
area.
so okay. Probably I did not reply, right? I did not reply you.
No, sir.
Okay. So here you must consider it as the region. Okay, not surface area. Understood?
Okay.
Okay, let me take that.
স্যার
Yes.
স্যার অ্যাসাইনমেন্টের ডেডলাইন তো 12 তারিখ দিয়েছেন, ওই দিন তো আবার টি এর অফিস আওয়ার নেই কোনো।
তাহলে 11 তারিখ দিয়ে দিবা।
স্যার 11 তারিখটা শুক্রবার, কালকে।
তাহলে 13 তারিখের মধ্যে অবশ্যই জমা দিতে হবে।
ওকে স্যার।
Okay. Number 1, number 2,
Present, sir.
3, 4, 5,
Present, sir.
6, 7, 8, number 9, 10, 11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14, 15,
Present, sir. Sir, 15 present.
16,
Present, sir.
17,
Present, sir.
18, 19, 20, 21,
Present, sir. 20 present.
okay, 21, 22, 23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Yes, sir.
27, 28,
Yes, sir.
29,
Yes, sir.
30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Yes, sir.
34,
Yes, sir.
35,
Present, sir.
36, 37, 38,
Sir,
Present, sir.
37. Sir, 37.
39,
Present, sir.
40,
Present, sir.
41,
Present, sir.
42,
Present, sir.
43,
Present.
44.
Present, sir.
Okay, anyone else?
Sir, Ikra binti Ismail.
Please. Number 6. Anyone else? Okay, let me submit. Okay, so we can stop here. Sorry, I have taken a little bit more today. Okay, see you in the next class. Of course, next class should be offline. Okay, thank you.
Thank you, sir.
Okay, welcome.